Hello guys. I hope you guys enjoyed our short little story about our aliens. Now I want to ask you guys, what did we learn about alien abductions? Probably nothing. But what we did learn is how to assign chiral centers RNS configurations. R would be that the chiral center rotates clockwise. S would mean that the chiral center rotates counterclockwise. Okay? In order to find these configurations, we came up with a sentence, or an acronym. The sentence is, interested aliens look really diligent. The first part, which is I, really stands for identify the first four groups attached to the chiral centers. The reason why this is important is because we want to make sure it is a chiral center. We want to make sure that it is four different groups attached to the carbon center. After we identify all the groups, we want to now assign priorities, which goes on to our second part, which is assign priorities. The first step to doing this is to find out the atomic weights. The atom with the highest atomic weight would be assigned priority number 1. The atom with the lowest atomic weight would be assigned priority number 4. And in the middle, it'll just be according to atomic weight 2 and 3. Now, sometimes you come across an atom where it's a little bit more confusing. As you can see, we have a chiral center. 4 different groups, but the chiral center is connected to 2 carbons. So our first step to finding out the priorities will not work in this case because carbon and carbon both have the same atomic weight, obviously. So we'll just add in the number 1 and 4 priorities. Now, in order to find the last 2 that's missing, we go on to our next step, which is look for first point of difference. Now, the way we do this is we just count off what atoms is attached to the atoms. Okay? These are both C's, so that's the first thing we look at. This carbon is attached to 2 hydrogens, so we'll say that we'll just put these on the list right here. Now, this carbon right here is only attached to 1 hydrogen because it has a double bond. Because of this, we count this carbon as 2 carbons and 1 hydrogen. Now, as you can see, we see a point of difference. Now, you may be asking, why is a double bond counted as 2 carbons instead of just 1? I will show you. Now, we could imagine this double bond looking sort of like this. Okay? As you can see, there's another carbon. There's 2 carbons. Therefore, it is counted as 2 carbons. If it was a triple bond, it would look something like this. As you can see, there's 1, 2, 3 carbons, which is why this will be counted as 3 carbons. Now let's move on. So, because of the double bond, this is assigned priority number 2, and this assigned 3. Now, we're almost there, guys. So, according to this, the 1, 2, 3 configuration would be an R configuration. But like I said, we're almost there. We're not there yet. These molecules are really in 3D. So I will draw this carbon in 3D now. to our third step, which is rotate molecule if fourth priority is in the front. Now, as you can see, the H is connected to the wedge, and the oxygen connected to the dash line. That means the hydrogen is in the front. So what happens with that is we have to rotate it to the back because we need the last priority to always be in the back. So instead of a R configuration, we will get this. We will get this, an S configuration, because we must flip the molecule in order for the H to be in the back. Okay? And that concludes how to find RNS configuration.